All right, you remember way back when, towards the beginning of the year, we talked about the local linearity aspect of some functions. And it was the idea if you zoom in on most functions at a particular point, it starts to look more and more like a line. And that tangent line at a particular point is the local linear approximation of the function at that particular point. But what's happening right here at this little point, this sharp turn, if you zoom in and you zoom in and you zoom in, it still looks like a sharp turn. Well, what does that mean if we're saying the tangent line is supposed to be the local linear approximation and we can't get one right here? And the tangent line's the derivative. Let's look at this kind of follow-up activity here. Tangent line at a particular point, local linear approximation of the function at that point. Use a graphing calculator to find the local linear approximation of each function at x equals 0. So number 2 is a little bit messed up. Let's come over here to here. Okay, so that's what it's supposed to look like. That's the greatest integer function. So we're specifically talking about at the origin. You know what? I'm pretty sure we've already done number 1. I'll do it again because I wanna. All right, so no, that's incorrect. So y equals absolute value of x, and local linearity goes, I'm going to zoom in until it straightens out to a flat line, and it just doesn't. Sharp turns? You can't get a tangent line there. It's never, ever, ever going to flatten out. Okay, so that's fine. Let's, okay, that's a better graph. All right, what else do we have? We have the greatest integer function. All right, on here, I think it's called floor. So I'm going to type in floor. You go away. F-E-R-R. Yep, look at that. It just automatically went to the function called floor, and then inside here I'll put x. Yep, there we go. It's that step function, that piecewise function. So let me go ahead and zoom in right there at the origin. Might be a little bit tough to see because you got red on top of that black. And hey, I've got a problem here. Sure, it's a flat line over here on the right-hand side, but I'm never, ever going to ever have anything over on the left-hand side. Well, I do, but it's further down. There's a big gap in between it. And notice what I have here at the origin is a point of discontinuity. Point of discontinuity. All right, and then there's one more. What was it? I think it's square root function. Let me just check just to be sure. Square root function, that's correct. All right. And you know what? I think we've already played with this one back there on that Desmos demo. And when I try to straighten this thing out by zooming in, it does get flatter and flatter, straighter and straighter at the origin, but what kind of tangent line is it becoming? It's becoming more and more vertical. So these 3 examples show us the 3 different ways in which a derivative is going to fail to exist. Let's summarize those things. So the first one here is a sharp turn. Sometimes they're called cusps. So if you have a sharp turn, the derivative changes from the left side to the right side immediately, right there at that point. It's not the same value on either side. The derivative fails to exist. Okay, the next one, super important. If you've got any kind of discontinuities, you're not going to have a function. You're not going to have a derivative at that particular point. Discontinuities. And then the last one, what was happening at the origin on that square root function? You started having a vertical tangent line. So there's another place. These are the 3 places where the derivative of a function is going to fail to exist. Sharp turns, discontinuities, vertical tangent lines. Here's a couple more pictures for you. Sharp turn right there. Sometimes again called a cusp. And then a discontinuity, not going to have a derivative right here at this particular point. And then finally a vertical tangent line. We looked at a square root function, but here the function is defined on both sides. Square root function wasn't, but still have a vertical tangent line. We're not going to have a derivative at that particular point.